Hi class, today we're going to be covering prefixes and equalities. This is chapter 2, section 4. So prefixes. A special feature of the metric system is that a prefix can be placed in front of any unit, the base unit, to increase or decrease its size by a factor of 10. So the metric system works on a factor of 10. So for example here, if we look at milli and micro, and first thing you need to do is look here, and the base unit is gram. So by adding milli, we now have changed these units to milligram. Same thing here, we had gram as the base unit, we now have microgram. One of the things you will definitely have to learn here is what these symbolize and what they actually mean. So this is microgram. In chemistry, we use the first one. In your field, medical field, you may use this as microgram. They mean the same thing. But in this class, we will always use this first one. So how do you do this? You take the base unit, in this case, 1 meter. 1 meter here equals 1 m. And we add a prefix to it. So we added kilo. Kilo is by definition 1,000. So if we change this wording to a number, we add 1,000 in front of the meter, and it is now 1,000 meters. Same over here, base unit is 1 gram. We add kilo in front of gram, it is now 1,000 grams. So this is how we use prefixes to either increase what it is that we're measuring or decrease. Here is an example of recommended amounts, and you can see that calcium's 1 gram, for instance. Iodine is 150 micrograms. Micrograms is used in selenium and below, and zinc is 15 milligrams. So it is used, and this is an example of why you need to know the metric system. Here is the metric system that we'll use. This is below kilo is a base unit, so it would be 10. Anything above it increases in size. So it goes kilo, mega, giga, tera, and peta. I really have never touched peta ever. So in tera, we would probably do it as practice, but we're mostly going to be dealing with very small amounts. So we're most likely going to be on the other side of this. But it starts here, kilo being the smallest, peta being the largest. And if you need to confirm that, just look at all the zeros in front. Scientific notation, and these are the equalities to be used. If we go on the smaller side, the base unit would be here and everything going down. So deci is small, but femto is the smallest out of all of these, and it goes in this way. You would need to know the name. You'll need to know the symbol, and you'll actually need to know these measurements because they will not be given to you on an exam. Yes, we're at home, but when we take a quiz or exam, you will only have so much time, so you will not have time to be referencing these things. It would be as if you were in a classroom environment. Here is a condensed. What the book gave us is two separate, and I didn't like that. This doesn't have all the information, but it gives it to you all in one place so you can see everything in one page. So these are the larger ones. Like I said, we never really go higher than this. And kilo, and if you see right here, the numbers jump. So you see these are all positive. These are a lot of zeros. These are like scientific notation. They are on the right side with these many zeros in front of the value that we want. So you can see it gets really small. And in the middle, you see that it goes from deci to kilo. Right here is our base unit. It would just be 10. I found this online. You can find any of this stuff online. This pretty much gives you a lot of information and a visual. And here is the base unit I'm talking about. So you see it jumps. We have these here. We didn't show you hecto and we didn't show you deca because we really don't use them. We either jump from this to kilo, but it could be thrown out there. If I cover something with it, I definitely will let you know. It's not a surprise, but deca and hecto, oddly enough, we don't really use that much. We tend to use these more because we're dealing with smaller amounts. You don't want to, give something to a patient in these larger amounts. It's just not, what we plan to do. So let's get started learning these prefixes. So we have 1,000 meters. 1,000, I told you, is This here, if you get confused on what these are, just enter these into your calculator. They'll usually spell them out completely what it is. So if you plug this in, it's going to come back as 1,000. So 1,000 is kilo. So we would write 1 kilo here, and this means 1,000 meters equals 1 kilometer right here. Now we go to the next one, and this is 10 minus 3. So find 10 minus 3. It's right here, or 10 to the negative 3 exponent, and it is m. This is a small m. The base here is gram. The base here is meter. So just because you see an m here doesn't mean that it goes, it's milli. It's the meter. The back second unit, so for instance here, the second unit is meter. The first one is the prefix. It goes in front. That's the one that has to deal with numbers. This is the unit that we're using. So this is meters, this is grams, and it's negative 3. Look for the negative 3. This is milli. So this is going to be 1 times 10 to the negative 3 is milli, so it is a milligram. And you can fill it out either way. You can fill it out like this, or you can fill it out with this. And if you're wondering how these fit in, if you go to the first page here, and you go to milli, there it is. 1 times 10 to the negative 3. They use seconds as the example, and 1 ms. You can go to kilo. Kilos here. 1 meter equals 1 minus 10 to the negative 3, or 1 kilometer equals 10. This is actually just 1,000, but it's not, it's in scientific notation. So you can always refer back to those, and I strongly suggest you do get used to looking. These are all this is in your book, so you can reference these as you're going through this. And then we have negative 2. So if we look at negative 2 here, this is in scientific notation. This is with it in standard form, is what they would call this, standard notation form. So this is where getting comfortable with scientific notation comes in hand. So if we look at this, 10 to the negative 2, it's centi. So 0.01 meters equals 1 centimeter. And if we jump through, there it is right there. So another thing to test you is you're going to have to know what's on the large side and what's on the smaller side, and in the hierarchy that's given to you. You're going to need to know, is milli greater than deci? Is centi greater than giga? You need to know these things. So here is a question: 1 milligram or 1 megagram, which is larger? So the base unit is gram. This is a capital M. This is a small m. So look at all the zeros that are here. There's 10 to the 6. This is 10 to the negative 3. Anything with the negative means that it's on the other side of the decimal point. So obviously, just by writing these out, you can see that megagram is much, much larger than milligram. So how do we use these? Well, we use them with measuring length. And we are going to do a lot of problems that you're going to start using this a lot, and hopefully you'll pick up on how these conversions come. One of the things here, the easiest ones to learn, is 1 meter. This is a meter stick. So 1 meter equals 100 centimeters. It also, excuse me a second, sorry, my cat wanted out. 1 centimeter is 100 centimeters. So if you look at this, if you hold a meter stick, it has these increments. This means 100 centimeters. But it also, because there's smaller increments in between the centimeters, also means it's 1,000 millimeters, excuse me. And then 1 centimeter, if you get a magnifying glass, 1 centimeter has 10 millimeters in between it. So 10 of these little increments equal 1 centimeter. So everything has, and here it's you have to figure out what it is that you need and pull that conversion for it. Do you need bigger or do you need smaller? Measuring volume. Volume, we use liter, deciliter, milliliter. In this class, we'll probably use liter or milliliter more than deciliter. And measuring volume, here's again another example of some normal laboratory test values: grams over deciliter, micrograms over deciliter here, megagrams over deciliter, and so forth. So you see the trend that's going on with these. The cubic centimeter, you will probably use this one more than a lot of them because we're going to be covering density in 2.7, and we will use both of these units here. So the first of the front two. So this is 1 cubic centimeter, 3 means cube, equals 1 milliliter. Equals 1 cc. We don't really use 1 cc in this class, in fact, at all. But we do use these first two. and they are interchangeable. This is for a volume, this is for a solid. So how do we use this? It's easier. This is a horrible picture that the system of the people that do the book gave me, but it is what we have to use. So if you look at this cube, so think of volume. Volume is 3D. Length is distance. It's one-dimensional. Area is two-dimensional. So if you think of area, it is trying to measure a rug for a room. You do length times width. Volume is 3D in a sense that if you drink a bottle of water, it's got length, it's got width, and it's got height to it. So you have to account for that. So I wrote it out better here. So if you see, this cube is 10 by 10 by 10. And when you multiply, you also have to multiply the units as well. So this is either 1,000 centimeters cubed and also 1,000 milliliters. And it also equals 1 liter. So if we pull one of these little squares out, and they all have identical sides, it's 1 centimeter. So it's length times width times height as well. And that's 1 centimeter cubed, which is equal to 1 milliliter, which is equal to 1 cc. Measuring mass, same thing. We would use this in what conversion or what unit that we need. Do you need kilogram? Do you need grams? 1 gram equals 1,000 milligrams. 1 gram also equals 100 centigrams. So these are things that we definitely are going to need to learn and be very comfortable with. Identify the larger unit. So let's just go through these and then we'll take a guess if we're right. So millimeter over centimeter. So we have a C and we have an M. This has a smaller number. Yes, it's a negative. It's a 3, but it's a smaller number than this one. It's a larger number than this one. So remember, think of place values. We have tenths, we have hundreds, and we have thousands. So this goes more out into the thousands, where this one goes into the hundreds. So this is actually a larger value than this one. Kilogram over centigram, that's easy. Kilogram, you see it's a positive number. Centigram is negative. So the value is on the right side of the decimal. This is not. This is just a positive number. And milliliter over microliter. So milliliter is here. Microliter is right below it. Remember I told you there's like a hierarchy here. The further you go down, the smaller the value is. And the more you go up, the bigger the value is. So if we look at these, we see millimeter, centimeter. So yes, centimeter is larger than a millimeter. And a kilogram is much larger than a centigram. And a milliliter is larger than a microliter. So this is a good way to test your knowledge and to make sure you start learning how to do these, learning the prefix, learning the symbol, and learning the meaning. These are 3 things you absolutely need to know in chemistry to be successful. This has to do with our calculations, and if you even go into chemistry more, this will never leave you. You will have to learn the foundation to be successful. And that's it.